Okay, this is 6.4, transformations of trigonometric functions. So this is pretty much a direct review from grade 11. The only difference here is that we're working in radians as opposed to degrees. Okay. The following transformations are applied to the graph of y equals sine x between 0 and 2 pi. So in other words, between 0 and 360 degrees if we were working in degrees. And we should all be familiar with the graph y equals sine x. So it looks like this, where this is now 2 pi and this is pi. Okay. So here are the transformations. A vertical stretch by a factor of 3, so we should know that that is the a value. It goes in front. A horizontal compression by a factor of 1/2. We should know that that's the reciprocal of that is the k value, which goes in front of the x, right? So it would be 2x here. A horizontal translation of pi over 6 to the left, so we should know that that's adding pi over 6 to the x value. And a vertical translation of 1 down, so we're minusing 1 off the equation. Alright? So all of those changes look like this in the finished equation down here. 3 sine 2 x plus pi over 6, close bracket, minus 1. Any questions on how we went from here to here? Because that's a big part of a review, right, from grade 11. Any questions? Do I have to explain each variable? Are you guys all good with that? Everyone's okay with that, right? So from here to here, we know what all these translations do. There's absolutely nothing new there. Okay, there's several ways that we can graph this. Okay, actually there's kind of two main ways. One is that we find the key points and we move them kind of one step at a time. So that's the first solution here. It says use the transformations above to sketch the graph of the transformed function in the interval between 0 and 2 pi. I don't like this method. Okay, we're gonna show it to you quickly, but I actually really prefer the next method. It's a tremendous amount faster, the next method, but we'll see. So the first thing we do is we just give key points of x, so 0, 90, 180, 270, and 360. We find the sign values. So there's the parent function. Once we have the parent function values, we do the stretch and compressions to those coordinates first. Okay, so there's the parent coordinates, and now we make the appropriate compressions. So we multiply it by 1/2 to do the compression, and then we multiply it by 3 to do the stretch, the vertical stretch. And again, that comes right from this formula here. Okay, remember multiplying it by the reciprocal of the k value and multiplying it by the a value directly. So then we get these new points for the stretched and compressed graph. And finally we do the final transformations down here, where we make the x coordinate movement and the y coordinate movement, again based on this equation over here. So we're adding pi over 6, we're subtracting pi over 6 from the x values. Remember, it's always the opposite for the x. And we subtract 1 for the y. So from all the y values you subtract 1. Okay, then we have our new coordinates for our newly transformed graph here, and we can go ahead and plot those coordinates. And we have our original graph, which is in green. Then we have the stretched to compressed graph in red. So that's the vertical stretch of 3 and a horizontal compression of 1/2. That's red. And finally, we make the final transformations and move it to the blue graph. So it moves down 1 and to the left 30 degrees or pi over 6. Any questions about that? Okay, that's the long way to do it. Went through it really quickly. The short way is even quicker. So here, using the features of the transformed function. So we know it has an amplitude of 3. Remember, amplitude is from the equation of the axis to the maximum point or to the minimum point. Okay, it's an absolute value. We know the period. Okay, the way the period works, it's always 2 pi divided by k, where k is the coefficient where k is that coefficient in front of x, right? This is also review. You guys remember that? Okay. All right, so there's our period, which is pi. We know that because our coefficient k here is 2, so we divide it by 2, so we get a period of pi. And our equation of the axis is y equals -1. We know that because the whole thing is moved down -1 here. So taking all this information now, we can actually go right to the final graph. Okay, we put the equation of the axis at -1. We know the amplitude is 3, so we go up to 2 and we go down to -4. And we know the period is pi, so we know we're going to complete 2 full revolutions in 2 pi. Okay, the last part is we just have to do the transformation on the x. So the horizontal transformation. Notice how this graph here doesn't have this part up here, the plus pi over 6. So that's the only last part we need to incorporate. And all we're doing there is we're moving the entire graph 30 degrees or pi over 6 to the left. Because it's positive here, this whole thing moves to the left. Okay, so we'll see that in the final graph here in blue. Okay, the way you move it over is you take key points, so maximum and minimums, and just move them the amount. In this case, pi over 6. It's always good if you're graphing this to make the axes, or sorry, the grid coordinate points in line with how much you need to move it. You see that? So they made each point 30 degrees here, or pi over 6. See how they did that? So 1, 2, 3, 4, 5, 6 is pi. You guys see how they did that? They chose the grid coordinates to be pi over 6. Why'd they do that? So now the points can move exactly 1 grid point over. Remember, that's your choice when you're graphing. So it's always important to look at this value, however much you're going to slide it, left or right, and create your coordinate axis accordingly. Any questions about that? It's okay, you can leave it, dude. So as you can see, I hope this is a lot easier than making that table of values. Okay, so you should know how to make the table of values and where it comes from, but this way is going to be a lot quicker and a lot easier. Okay, any questions? All right, let's look at a word problem here. A mass on a spring is pulled towards the floor and released, causing it to move up and down. The height in centimeters above the floor after t seconds is given by the function this between 0 and 3 seconds. Sketch a graph of height versus time. Then use your graph to predict when the mass will be 18 centimeters above the floor as it travels in an upward direction. So we have height here, we have time here. We're going to go up to 3 seconds.